Your RF exposure is 3%. What does that actually mean? Today, radio waves are everywhere, and regulatory authorities upgraded exposure assessment methods by a number of aspects. While complicated methods are applied, exposure is expressed through a simple percentage, like 3% of the limit, for example. There is no need to be an expert to understand a percentage. Okay, but percentage of what? Our viewers interested in RF would like to know how that value is actually determined. It's no longer just about a radio tower in the neighborhood. Several radio services are found practically in all situations of life to be taken into account. Let's briefly look at an Excel from an earlier video, which is computing the electromagnetic field strength at a certain distance from the transmitter. There are already entries for a neighboring 10-meter amateur radio antenna transmitting almost 750 watts, which is only 3 meters away from me, as well as an 868 MHz LoRa transmitter transmitting 20 dBm and a 2.4 GHz PC Wi-Fi adapter, both of which are on my desk. Our tool is computing the field strength, or correctly phrased, the power flux density, in case of free space wave propagation. It's practically the worst case, because the radio signals are reaching me non-obstructed. In the graphic, we see limits for the power flux density that were defined several decades ago by regulatory authorities for the occupational and public case. Feel free to watch the earlier episode. Officially, this terminology doesn't exist, but among us I'm simply calling this the first approximation. The power flux densities are well below the limits, which are not the same for all frequency ranges, as you can see. The scenario is getting more interesting, considering my 5G smartphone in my pocket. Its maximum radiated power in the 6 GHz range is 0.2 watts, and the distance to my body is only 1 centimeter. At least for a part of my body, the smartphone's peak field strength is more than an order of magnitude stronger than all other signals together. I must admit that the simple calculation is neglecting the near field, coupling additional RF power into my body. But regardless of whether you calculate the power flux this way, or precisely, or ultimately measure it, you will find values not far from this. Just as a hint, as long as there is one dominant radio signal, you can compare the power flux density directly with the limits in the graphic. In this case, you could even calculate the field strength back from an exposure percentage. In the presence of several signals, things are getting more complicated. The ICN-IRP has developed a definition according to which several signals are added together. I'm calling this the second approximation. Weighted signals are added over the entire frequency range. The result shall be smaller than 1 and is usually presented as a percentage of 1. The weighting factor for each individual signal is the reciprocal of a reference limit at the respective frequency. In addition, there is a similar calculation with the specific absorption rate, SAR, which is a measure for the radiation absorbed by the body per kilogram. The equation is giving us an exposure measure for all frequency ranges in one single number. As an effect of this, safety distance or maximum field strength allowed for an individual signal at a certain location is depending on the sum of the signals. By the way, more than 100% exposure doesn't mean that you wouldn't survive. It's simply the limits experts are considering to be harmless to health. There are 4 power flux densities in our example, which we are adding up as explained. I put them into my Excel table. As reference values, I'm using the limits from the old FCC paper for occupational and public. I can read the values for 30 MHz, 2.4 GHz and 6 GHz directly from the table. For 868 MHz, the frequency in megahertz divided by 300 or 1500 applies. Next, we are calculating the 4 quotients for both occupational and public, and finally we are adding them up. The results are 3.88% for occupational and 19.4% for public, telling us that the RF exposure is within acceptable limits. A disadvantage of that method is that the percentage doesn't tell us that my smartphone is dominating and the rest is orders of magnitude lower. We can only judge that by looking into the individual contributions. ICN IRP refined the procedure in 2020 even more, and I must admit that it's becoming really complicated. Specific absorption rates are differentiated for parts of the human body, as well as exposure times and scenarios, and somehow all of this is reflected in formulas. Let me call this the third approximation. Without any doubt, there are good reasons to take all this into account. The principal method is still the same, but with a complexity that I cannot explain in a short video. ICN IRP is delivering valuable regulations. Just take a look at their website if you are interested in the details. Serious RF exposure measurements are a domain for specialists and expensive measuring equipment. Nevertheless, as an interested hobbyist, you can at least estimate and roughly measure it, especially in case we are interested in a certain dominant signal only. There are a number of commercial measuring devices available. I will link you to a few examples below. We were even showing how to build a DIY RF power measuring device. When measuring RF exposure, it's not easy to understand what you are actually measuring. I hope this video is helping you a bit, and you are welcome to watch all our videos about the RF topics. Just as a side note, if your TV reception is disrupted, it's not immediately a reason to worry about your health. Instead, you can watch some videos on intermodulation here on the channel. Now, stay tuned and don't forget to support the channel. See you soon in the coming episodes.